Hello friends, I am Iseki Muthu, Maths faculty in Vidhyalakshmi NEET Academy. Already we have here 2 YouTubes regarding the relation and functions. This is the third one. In this, we are going to see the problems to check one onto by shortcut method. Let's go the problem. Look here. Check the following functions are 1 and 2. From first one, f from R to R. All the functions, it starts from R to R. It is given by first one, f of x equal to x by 2 plus 5. This function is of the form x by 2 plus 5. F of x equal to the first one, x by 2 plus 5. Look here, this function is 1 on 2. We have to solve the problem in shortcut way. First point, the power of x equal to 1 and by 2 is a constant. The second term is a 5 is also a constant. Therefore, it is a linear function. First degree equation means linear function. Linear function always represent a straight line. What is the relation between 1 and 2 with respect to a straight line? Look here. If you draw the straight line, whatever it may be, suppose you are putting x equal to 0. Look here, I am draw the graph for this. X and y. X equal to 0, the value equal to 5. X equal to 2, the value equal to 6. When 0 equal to here 5. And 2 equal to the 0.6, therefore join this, it is a straight line, it starts from minus infinity to plus infinity. It is a straight line from minus infinity to plus infinity. What is the important point regarding this straight line? It is in increasing straight line, strictly increasing straight line, and also our question is check one only. Draw a straight line parallel to x-axis. Draw a straight line parallel to x-axis. It is a x-axis. It is a y-axis. Now the straight line, it cuts the given curve at only one point. Therefore, automatically, it is a 1 function. It is a 1 function. F is 1. Look here. The function f of x equal to x by 2 plus 5 is a linear function. Automatically it is a 1 on 2. Even though I am giving one more explanation, draw the straight line this way, the chart xy 0, 5, 2, 6, the straight line. Draw a straight line parallel to x-axis, it cuts the curve at only one point. If it cuts the curve at only one point, it is a 1. So I am writing here f is a 1. What about on 2? Here you see that x equal to minus infinity, x equal to minus infinity, f of minus infinity also minus infinity, and f of plus infinity also plus infinity. It takes all values between minus infinity to plus infinity. No values are left over. Therefore, every element in the codomain should have the pre-image is a completely checked. Therefore, it is a on 2. F is on 2. This function is f is 1 on 2. I am not giving the option A, B, C, D. We are discussing the function, the nature of the functions about 1 and on 2. Here the function is this form, linear. Automatically we can tell that it is a 1 on 2. Even though I am giving the draw the graph and draw a straight line, it cuts the curve at only one point. Therefore, and also f of minus infinity equal to minus infinity, f of plus infinity equal to plus infinity. It takes all values from the y-axis which has the pre-images. Therefore, it is on 2. The first question is f is a 1 and on 2. Let's go for the second one. The second problem is f of x equal to x squared divided by 2 plus 1. You need not bother about the curve. Here x squared term is a given. It is a even function. Even function means in what is that? First point it is not 1. What about the onto? Negative values don't have the negative values don't have the pre-images. Therefore, it is also not 1, 1, not on 2. Even though I am draw the graph for this. Here, y equal to f of x, which is equal to x squared divided by 2 plus 1. Here, x squared coming, the curve is symmetric about y-axis. The curve is of the form, here it's coming this way. Y equal to x squared divided by 2 plus 1. It is symmetric about y-axis. It is symmetric about y-axis. It is a x-axis. Now the horizontal line checking. Draw a straight line parallel to x-axis. It cut 2 points. Whenever it cuts more than 1 point in the given curve, therefore f is not 1, 1. For MCQ, we have to go through the shortcut way. And the first point is over. What about the second point? You take any value here, minus 2. Minus 2 not in the curve. Therefore, it has no pre-images. We are taking f from R to R. Minus 2 belongs to the codomain, which has no pre-image. Therefore, here f is also not on 2. The first one, second one is also discussed. What about the third one? Let's go for the third one. I once again recall the problem. F of x equal to x squared by 2 plus 1. Without drawing the graph, we can also discuss the nature of the x squared. X squared is not 1 and also not on 2. The same result can be extended for this. Therefore, it is not 1, 1, not on 2. But we also give another proof method. Draw the graph is of the form. The graph, now draw a straight line parallel to x-axis. It cuts the 2 point. Therefore, is not 1, 1. And minus 2 belongs to the codomain, which has no pre-image. Therefore, is also not on 2. Okay, now I am going for the next one. Third one equal to f of x equal to root x. F of x equal to root x, we have to discuss the curve before the draw the graph for this. Look here. This is y equal to f of x. Y equal to f of x. That is y equal to root x. The curve is of the form. The domain of the function is equal to positive values 0 to infinity. Closed interval 0 to infinity. Domain of the function which is equal to closed interval 0 to infinity. Therefore, here only the curve existing. And now I am draw the graph for this. It is of the form which is equal to of the form y equal to root x. Now you have the conditions. It is a check 1, 1 and R2. Draw the straight line parallel to x-axis. It cuts the curve at only 1 point. Whenever the horizontal straight line which is parallel to x-axis cut the curve at 1 point, automatically the f is 1, 1. And what about the onto for this? It takes all values from here to 0 to up to infinity. But the negative value, my y equal to minus 1. Y equal to minus 1 have no pre-images. Therefore, it is also not on 2. F is not on 2. The curve y equal to root x, which is equal to the domain of the function equal to 0 to infinity, it is of the form this way. You must know the graph. After that, I am draw a small straight line which is parallel to x-axis, cut 1 point, immediately is a 1, 1. But on 2, I am taking a 1 point in the negative side minus 1, which has no pre-image. Therefore, is not on 2. I am going for the fourth problem. The fourth problem, f of x equal to c. Very good. Here, if you some points x, y, z, t, whatever may be, then here, see, all the values goes to the only one element c. Therefore, that is x is not equal to y here. The elements are different, which implies f of x equal to f of y, which is equal to c. Therefore, f is not 1, 1. The constant function is not 1, 1. What about that? It is on to, look here, 1 minute, small change I am giving. F of x equal to c. The domain of the function equal to 3, 2, 1, 0, minus 3, minus 2, minus 1, etc., etc. And the codomain, it contains only 1 point. Here, it's coming here, it's coming, all the values goes to c only. Therefore, take any 2 points, 3 is not equal to 2, implies f of 3 equal to f of 2, the value equal to c. The image elements are different, corresponding images are same. Therefore, according to our definition, f is not 1, 1. F is not 1, 1. Here we are not drawing any curve. But what about the onto? Now let's go for the codomain. The codomain from FR to R. FR to R means here the C is the only point has a value, and all other points here you take C plus 1 or any other value which has no pre-images. Y equal to some value not equal to C. I am taking C equal to C plus Y equal to C plus 2, which has no pre-image. That is a no pre-image in the domain. Therefore, is not on 2. F is not on 2. Hence, this function is not 1, 1, not 1, 1, but not and also not on 2. Here, this is the function is f is not 1, 1 and also not on 2. This function is a 1, 1. It is a 1, 1. F is a 1, 1 and also on 2. This is also f is not 1, 1 and also not on 2. This function is f is a 1, 1 and not on 2. That is, we are discussing the problem without the theory part, using the graph only, which is very useful for MCQ questions. Now, I once again coming here, clear the slide. This function, according to this, f is 1, 1 and on 2. And this function, f is not 1, 1 and not on 2. And this function, f is 1, 1 but not on 2. This function is f is not 1, 1 and not on 2. You see that without using x is not equal to y, that way we are using the graph. Any horizontal straight line parallel to x-axis, it cuts the curve at only one point. It is a 1, 1. If cuts more than one point, it is not 1, 1. For in order to check on to, take any point in the codomain which has no pre-image, then it is not on 2. Maximum for the square x power 4, 2, 4, etc. The even powers, you take the negative values only. Okay, and I am going for the next problem. The next problem, it is also checking for 1, 1 on 2. The function is f of x equal to x cube. Fifth problem, f of x equal to x cube. For this, you must know the graph of the function. I am draw the graph of the function. It is a very simple to solve it. Look here, the graph is of the form. It's coming here and cross the 0 and this one, which is equal to y equal to x cube. Our technique is to draw a straight line parallel to x-axis. I am draw the straight line. It cuts only one point. Immediately I am writing here f is a 1, 1. F is a 1, 1. What about on to f of minus infinity, which is equal to minus infinity, f of plus infinity equal to plus infinity. It takes all values from this one in the codomain. Therefore, the codomain contains minus infinity plus infinity have pre-images in the domain. Therefore, it is a f is also on 2. This function is a 1, 1 and on 2. The graph, you must know that some maximum 10 or 20 graphs you should keep in mind. Using the graph, you can draw the straight line parallel to x-axis, cut it in one point, immediately 1, 1. Now, more than 1 point means not 1, 1. And also check all the points are covered in the y-axis for on2. The problem is a 1, 1 and on2. I am going for the sixth one. Sixth problem, f of x equal to mod x. F of x equal to mod x. This graph also you must know that the x-axis, y-axis, and the graph is of the form, it is of the form, it's coming here and going here, which is equal to y equal to mod x. Now, you have, in order to check 1, 1 onto, the technique is to draw a straight line parallel to x-axis. It has here and here, 2 points. Immediately you can write that f is not 1, 1. But the codomain is a full area minus infinity to plus infinity. The area is covered here 0 to infinity only. I am taking y equal to minus 2. Y equal to minus 2 has no pre-image. only one sample is enough, has no pre-image in the domain of the function. Therefore, f is not on 2. This function is not 1, 1 and not on 2. The next one, the seventh problem, f of x equal to x into mod x. This problem somewhat differ. So first we have to expand the curve function f of x equal to, before that you must know that mod x, the curve equal to x and minus x. If x is a positive, greater than or equal to 0, if x less than 0. Therefore, I am also split into two, x if x greater than or equal to 0, if x less than 0. In this case, x into x, mod x value x. In this case, mod x value minus x. Therefore, this value x into x. Therefore, f of x equal to the two values x squared minus x squared, x greater than or equal to 0, x less than 0. The given f of x equal to x into mod x. We know that mod x equal to x if x greater than 0, minus x if x less than 0. Now, the f of x can be written as x into x greater than 0. X into minus x, therefore the value equal to x squared into minus x squared. This function. Now I am going to draw the graph for this. Look here, f of x which is equal to x into mod x, which is equal to, immediately you can write x squared minus x squared if x greater than or equal to 0, if x less than 0. In this step you write, immediately you can draw the graph. Look here, for positive side it is the function equal to x squared. X squared means it is symmetric about the x-axis. It is of the form this one. It is equal to minus x squared means it is symmetric about the y-axis in the negative side. This curve is y equal to x into mod x. Now you know the technique of check 1, 1 and 2, draw a straight line parallel to x-axis. It cuts the curve at only one point. Immediately you can write the answer, f is a 1, 1 and also f of minus infinity equal to minus infinity, f of plus infinity equal to plus infinity. Therefore, the function takes all values from minus infinity to plus infinity, it is on 2. This, after this step, it is f is on 2. This function is a 1, 1 and on 2. Now I am going for the next one, the eighth problem. The eighth problem, f of x equal to x power 4 plus 2. You don't bother about that, it is a very simple. Here the draw the graph is a somewhat difficulty. For this, I am using the technique of f of x equal to x squared plus 3. Yes, last YouTube we discussed this, x squared plus 3. This one is a f is not 1, 1, is not 1, 1 and f is not on 2. We know that f of x equal to x squared plus 3, immediately the answer is not 1, 1 and not on 2. Reason, x power 2. Same argument should be given for x power 4. It is a even function. So not even function, x power 4. The power is a 4. Therefore, automatically you can write is not 1, 1 and f is also not on 2. That's all. In this way, you have to touch the problem in this way. I am giving the summary for this. This function is, we discussed f is a 1, 1 and also on 2. Similarly, this function is f is 1, 1 and on 2. This function is f is not 1, 1 and also not on 2. Similarly, this function is equal to x power 4, x power 2. They have the same argument. F is not 1, 1 and not on 2. This is a right answer for the 4 problems. Instead of giving multi-choice question, we are giving this type of problem. It is notes for the MCQ. Now I am going for the next one, ninth problem. Ninth problem equal to f of x equal to square root of something given. Find the domain of the function. In order to find the domain of the function, the square root is coming. F of x equal to square root of the expression. the expression always should be greater than or equal to 0. If in the numerator, suppose it is in the denominator, f of x equal to 1 by square root of expression, then the numerator, the expression should be strictly greater than 0. These two conditions should be satisfied if the function is given this form. Now, the function is square root of 1 minus x into x minus 6. Let's go for this. Here, the expression inside the square root equal to 1 minus x into x minus 6. It must be greater than or equal to 0. The inside the square root. I need not write the function 1 second. I am taking the value from the inside the square root, this value. X minus 6 is no problem. 1 minus x should be written in the reverse order. Therefore, minus is taken outside. X minus 1 into x minus 6 greater than or equal to 0. I am multiplying all sides by minus. Therefore, x minus 1 into x minus 6 is less than or equal to 0. What are the domain for this? We have here one result. Look here, alpha less than beta and x minus alpha into x minus beta is less than or equal to 0. In this case, immediately the answer is this value, this is equal to alpha and beta. It takes all values lies between alpha and beta, this one. You have to take the result. Therefore, x belongs to the closed interval alpha to beta. Using this, here x alpha equal to 1, beta equal to 6, the domain of the function equal to the closed interval 1 to 6. We are using the result, the problem is immediately solved. Here, your square root of the term should be greater than or equal to 0 and that is a minus is taken outside, multiply by minus this value, it is of the same form. These two are same way. Compare this alpha equal to 1, beta equal to 1. Therefore, x belongs to alpha to beta. It means 1 to 6. Therefore, the domain of the function of the problem, domain of the function equal to closed interval 1 to 6. Suppose this problem in the denominator, look here. Suppose the problem f of x equal to 1 by square root of 1 minus x into x minus 6. In this case, you should be taken as is greater than 0 only. Should not take equal to simple. The corresponding change you should be noted. I am going for the next one. Next problem, f of x equal to x minus 1 into x minus 6. Find the domain of the function. Here, the square root is given. Therefore, it should be greater than 0. The square inside the square root, expression must be greater than or equal to 0. That is just like x minus alpha into x minus beta is greater than or equal to 0. This implies the x belongs to minus infinity to alpha, closed interval, union beta to infinity. Beta to infinity. This term it should be taken. Square root of this expression, inside the square root, this value, it is of the form x minus alpha into x minus beta greater than or equal to 0. Now, it has the value x belongs to minus infinity to alpha union beta to infinity. Beta to infinity. Therefore, in this value, the domain of the function equal to the minus infinity to 1 closed interval union 6 to infinity. This is a domain of the function. The same problem, both are the same problem, only difference of minus is inside. So, the corresponding change you should note it. Now, let's go for the next one. The next problem, f from r minus 1 to r defined by f of x equal to 1 minus x. Check it is a 1 1 on 2. Check it is a 1 1 on 2. Now, we are using the theory. What is the theory? The theory is equal to x is not equal to y, which implies minus x is not equal to minus y, which implies 1 minus x is not equal to 1 minus y, which implies 1 divided by 1 minus x is not equal to 1 divided by 1 minus y. This implies f of x is not equal to f of y. So, what do you have? X not equal to y, the different element have different images for this function. Clearly, the f is 1 1. Clearly, the function is a 1 1. Now, we have to check for onto. Look here, the given function f of x equal to 1 divided by 1 minus x. For the domain, denominator should not be 0. Denominator equal to 1 minus x equal to 0. X equal to 1 should be removed. Already removed. Domain of the function. Then 1 minus x is not equal to 1 minus y. Next step. Then finally, f is 1, 1. What about onto? For onto, we have to find the inverse of the function. Y equal to f of x. Y equal to f of x, which is equal to 1 minus 1 divided by 1 minus x. That is y equal to 1 divided by 1 minus x. 1 minus x equal to 1 by y. And then 1 minus 1 by y equal to x. That is x equal to 1 minus 1 by y. On simplification, this value x equal to. Now f inverse of x equal to x minus 1 divided by x. This is the domain range of the function. Range of the function equal to domain of the f inverse of x, which is equal to, take it all values of r except 0. Except 0. 0 belongs to the codomain, have no pre-image. 0 belongs to the codomain of the function, has no pre-image. Therefore, f is not on 2. This function is 1, 1 but not on 2. Look here. X not equal to y I am taking. Implies minus x is not equal to minus y. Implies 1 minus x is not equal to 1 minus y. Then taking the inverse for this. And this equal to f of x. It is equal to f of y not. Different elements have different images. F is 1, 1. For y equal to f of x. That is I am finding the inverse of the function. It is a usual procedure. Then what is the domain of the range of the function equal to range of the f inverse domain of f1 equal to r minus 0. That is the range of the function equal to r minus 0. The 0 has no pre-images. Has no pre-images means f is not on 2. That's all. The next one. Next problem. F of x equal to log x into log x of x plus 1 to the base 3. Domain of the function. Look here. We know that the log function log x to the base a is defined. The function is defined if the x greater than 0 and also a greater than 1. Now the log function equal to log x plus 1 to the base 3, which is equal to f. Here 3, no problem. The argument x plus 1 should be greater than 0. It's greater than 0. X greater than minus 1. Therefore, it takes all values from x equal to minus 1 to infinity. X equal to minus 1 to infinity. The domain of the function equal to open interval minus 1 to infinity. Open interval minus 1 to infinity. Look here. The log function x plus 1 to the base e. E is a greater, the base 3 greater than 1, you don't bother about it. X plus 1. The x plus 1 always greater than 0. The logarithm, in the logarithm, the value always greater than 0. X plus 1 greater than minus 1. I am marking the point in the real line. These two up to minus infinity. Plus infinity. Therefore, the domain of the function equal to open interval minus 1 to infinity. Now I am going for the next one. That is, if n equal to n of a equal to 4 element, n of b equal to 3 element, find the number of 1, 1 functions from a to b. F from a to b, find the number of 1, 1 functions from a to b. It is a formula. What is the formula? It has a 2 formula. If the order of b is greater than or equal to order of A. Otherwise, if order of B less than order of A. If order of B greater than order of A, B is a bigger set than A. Then the value equal to order of B, the permutation of order of A. This value equal to 0. Here order of A equal to 4 and order of B equal to 3. Which case is suitable? Look here, this case is suitable. Order of B less than order of A. Therefore, the number of functions from A to B equal to this value equal to 0. There is no 1, 1 function from A to B in this case. Next one, let's go for the next one. This function f of x equal to log x plus square root of x squared plus 1. The square root is extended up to this also. Check is a even function or not. We have recalled the definition of even or not. F of x equal to f of minus x. Change x into minus x. There is no change in the function. It is a even function. F is a even function. At the same time, f of x equal to minus of f minus x, which is equal to odd function, is an odd function. This is the definition for even and odd. Now, the given function f equal to f of x equal to log x plus square root of x squared plus 1 is even or not. It is a simple problem. You also know that. What about f of minus x? Change x into minus x. That is a log minus x plus square root of minus x whole squared plus 1. This value equal to log minus x plus square root of x squared plus 1. Now I am taking the multiply both numerator denominator by the conjugate of this value. That is equal to log the value square root of x squared plus 1 minus x into square root of x squared plus 1 plus x whole divided by square root of x squared plus 1 and plus x. Look here, f of x given this value. I am changing x into minus x. Now the change, I am writing this way. Now multiply both the numerator denominator by the conjugate this value. A minus b into a plus b. Therefore, the value equal to logarithm of that value x squared plus 1 minus x squared divided by square root of x squared plus 1 plus x the value. Cancel these two terms. Now the leftover equal to logarithm of 1 divided by square root of x squared plus 1 plus x. This value equal to minus logarithm of x plus square root of x squared plus 1, which is equal to minus of f of x. Hence, what we have equal to, we starts with minus x, which is equal to minus f of x. Therefore, this function is even or odd. We have to check it. Look here. F of x equal to this value given. F of minus x equal to this value. And taking the conjugate for this, I have a minus b into a plus b. This value equal to x squared plus 1 minus x squared, cancelling this value. It is equal to log 1 minus log x plus square root of x squared plus 1. Log 1 value equal to 0. Therefore, is minus f of x. Therefore, f is odd function. A function is even or odd. This also we must know that. In order to, next 4 problems are related with this. I am going for the next one. This function f of x equal to f of x equal to x squared. Whenever power is even, is automatically even function. Need not check it. And the power is odd, automatically it is a odd function. It is a odd function. F of x equal to mod x. Here we check it. F of minus x equal to mod minus x, which is equal to mod x, which is equal to f of x. Therefore, it is a even function. And the last one equal to f of x equal to cos of minus x. Cos of minus theta equal to cos theta. This value equal to cos x. This is equal to f of x. Taking these two, f of minus x equal to f of minus x equal to f of x. This implies f is even function. That is, we discussed 15 problems in such a way that here the first one even, second odd, third even, fourth also even function. Even function. Okay, the 15 we checked. Now, first YouTube you have seen and second YouTube also you have seen. Third one, here next class we will